Figure 20.31, Basic Searching and Sorting Algorithms of the Standard Library. In this example, we'll take a look at several different ways to search through a container and also to sort the contents of a container as well. Now, we begin here in lines 15 and 16 with a constant integer size which has the value 10 and an array of integers with that size. And then we use that array to initialize our vector called v at line 17. And of course we have an output stream iterator that allows us to output to the standard output stream with spaces between values, and we use that here at lines 20 and 21 to show you the initial contents of the vector v, and you can see that here in the output. Now, the first thing we're going to do is use the find algorithm, and basically what it does is it locates the first occurrence of a value that you specify in a range of elements of a collection, and it returns an iterator that's aimed at that location. So here at line 24 we've declared a vector of integer iterator called location, and we're assigning to that the result of this find algorithm call. And you can see here that we're iterating through the entire contents of the vector v. Again, we don't have to do the entire contents, we are choosing to do that here. And we're looking for the first value 16 and where it is located within the container. Then at line 27 through 30 we check that location to see if it's not equal to the end iterator. That would mean that we found it. If it's not equal to the end, we subtract from location v.begin, and that tells us the position number where we found the value. Otherwise we'll print out 16 not found. Now if you look at the original collection, you can see clearly that there is a 16 there, and it's at position 0, 1, 2, 3, 4, position number 4 within the container. So if I stop there and take a look at the output, you can see that it found 16 at location 4. That's the actual index number. And similarly, we search for a value that's not in the container. So here again is the original set of values. We're searching for 100, which is not in that set of values, and in this case lines 35 through 38 will print out that 100 is not found. Now we continue with the find if algorithm, which is very similar to find, except instead of finding a particular value, it finds a value that matches a certain criteria specified by a function that receives that value as an argument, receives a value from the container as an argument, and returns a Boolean indicating whether or not the value matches the criteria. So if you look at the greater 10 function, you can see here it receives an int, and it returns whether value is greater than 10. If it is, it returns true, otherwise it returns false. So basically in this example we're searching through the vector looking for the first value that's greater than 10, and we're going to get back an iterator pointing to that location. And at line 43, if the location is not equal to v.n, that means that there was at least one value that was greater than 10. We're going to show you what that value was and what index number it was located at by subtracting from location the value of v.begin. So if we stop there and take a look at the output, we see that the first value greater than 10 was 17. So we had 10, which is of course not greater than 10, 2, and then 17. And we see that that 17 in the original vector is at position number 2, and it says here that it was found at location 2. The next thing we do is sort the vector's contents, and again you can look at the original vector to see that it was not in sorted order. So here when we call sort, we give it v.begin and v.end as arguments. Now before we look at that in more detail, let's take a look at sort in the online doc set, and you can see that sort requires random access iterators, which means this algorithm can be used only on vectors, decks, and also the regular C++ concept of an array. So we sort the vector, then we display its contents, and of course after sorting we're going to see the items in ascending order. And that's important for the next operation, which is the binary search algorithm. Binary search requires that the items be in sorted order, otherwise it will not work correctly. So it's up to you to make sure that the items are sorted before you call binary search. And in binary search we're going to give it the range of elements to search through and the value that we're looking for. It's going to return an indication of whether or not that value is found. So if you look at the binary search algorithm in the online documentation, you can see you can see here that binary search just returns a Boolean indicating whether or not the value is contained within the container. So it's not as precise as the find algorithm, which tells you the actual location of the value. So basically, binary search will return true if 13 is in the vector and false otherwise. If it returns true, we'll print out that 13 was found. Otherwise, we'll print out that it was not found. And you can see here that 13 is in the vector and 13 was found. And then finally we search for a value that's not in the vector, and we see that 100 was not found inside this vector v. So again, these are the various different searching and sorting capabilities. Please be aware that the binary search is not as capable as the find algorithm in terms of telling you precisely where an item is located. The find algorithm gives you an iterator pointing to that location, whereas binary search only tells you true or false. The value is either in or not in the underlying container.